Welcome to our exploration of the fascinating world of natural light sources. From the moment the sun rises to the twinkling tapestry of stars, we are bathed in nature's illuminations. Our journey begins with the most familiar and vital source of light, the sun, the star that has been central to life on Earth for billions of years. This colossal ball of burning gas, a star at the heart of our solar system, bathes our planet in warmth and light, making life possible. Deep within its core, a nuclear fusion reactor churns, converting hydrogen into helium and releasing an unimaginable amount of energy, sustaining the sun's brilliance. This energy travels millions of miles through the vacuum of space, eventually reaching our planet and providing the energy necessary for life. It drives photosynthesis, the process by which plants convert sunlight into energy, forming the foundation of most ecosystems on Earth and supporting the food chain. The sun dictates our days and nights, governs the seasons and influences weather patterns, shaping the climate and environment. The angle at which sunlight strikes the Earth's surface varies throughout the year, creating the familiar patterns of summer, fall, winter, and spring. Sunspots, dark blemishes on the solar surface, indicate areas of intense magnetic activity, which can have significant effects on space weather. These sunspots can erupt in solar flares, bursts of energy that release X-rays and ultraviolet radiation towards Earth, impacting satellite communications and power grids. As darkness descends and the sun dips below the horizon, a new spectacle of natural light takes center stage. The stars. Scattered across the vast canvas of space, these twinkling points of light are celestial furnaces, much like our own sun. Within the cores of these distant suns, nuclear fusion reactions convert lighter elements into heavier ones, releasing vast amounts of energy. This energy radiates outward, traveling for millions, even billions of years before reaching our eyes as starlight. The colors of stars, ranging from cool reds to searing blues, reveal their temperature and age, providing astronomers with clues about their life cycles. The patterns we see in the night sky, the constellations, have guided navigators and inspired storytellers for millennia. Fire, a chemical reaction that produces both heat and light, has captivated humans since the dawn of time. Whether a raging inferno or the gentle flicker of a candle flame, fire represents both creation and destruction. The process of combustion, the rapid chemical reaction between a substance and an oxidant, usually oxygen, is at the heart of fire. This reaction releases energy in the form of heat and light, creating the characteristic flames and glow associated with fire. For early humans, fire provided warmth, protection from predators, and a way to cook food, forever altering our relationship with the natural world. The control of fire marked a pivotal point in human evolution, paving the way for the development of agriculture, technology, and ultimately civilization itself. Few natural phenomena are as awe-inspiring and terrifying as a thunderstorm. The deafening roar of thunder, the blinding flash of lightning, a dramatic display of nature's raw power. Lightning, a sudden electrostatic discharge that occurs within a cloud, between clouds, or between a cloud and the ground, is a spectacular example of electricity in action. As storm clouds gather, friction between ice particles within the cloud creates static electrical charges. When the electrical potential difference becomes sufficiently large, a sudden discharge of electricity, lightning, occurs. This electrical current can heat the surrounding air to temperatures hotter than the surface of the sun, causing the air to rapidly expand and create a sonic shockwave that we hear as thunder. In the depths of the ocean, where sunlight fades into an eternal twilight, a different kind of light show unfolds. Here, creatures have evolved the remarkable ability to create their own light through bioluminescence. This living light is produced by a chemical reaction within the organisms themselves, converting chemical energy into light energy. One of the most iconic examples of bioluminescence is the firefly, a nocturnal beetle that uses flashes of light to attract mates. In the deep sea, bioluminescence is not just a means of communication, but a vital survival tool. Deep-sea anglerfish, for example, use bioluminescent lures to attract prey in the pitch-black depths. While bioluminescence is most often associated with animals, the plant kingdom also holds a few surprises. Certain species of plants have evolved the ability to emit their own ethereal glow, a phenomenon known as plant bioluminescence. This ethereal light is produced through a similar chemical process to that found in bioluminescent animals, involving the interaction of luciferin and luciferase. The reasons behind plant bioluminescence are not yet fully understood, but scientists believe it may play a role in attracting pollinators or deterring herbivores. Venture into the heart of a forest at night and you may be treated to a magical sight: mushrooms that glow in the dark. These fascinating fungi, known as bioluminescent mushrooms, possess an otherworldly beauty, their caps and gills emitting an eerie, ethereal light. The bioluminescence in mushrooms is caused by a chemical reaction involving luciferin, luciferase and oxygen. The exact purpose of this glow in mushrooms is still a subject of scientific debate, but some theories suggest it may attract insects which then help disperse the mushroom's spores. Over 70 species of bioluminescent mushrooms are known to exist, each with its own unique glow pattern and intensity. These glowing fungi, often found in decaying wood or on the forest floor, add an element of magic and mystery to the natural world. In the high-latitude regions of our planet, a celestial ballet of light unfolds, painting the night sky with vibrant hues of green, blue, red and purple. These mesmerizing displays are nature's own light show, captivating all who witness them. These are the auroras, also known as the Northern Lights, or Aurora Borealis in the Northern Hemisphere, and the Southern Lights, or Aurora Australis in the Southern Hemisphere. Both phenomena are breathtaking in their own right. These spectacular displays of light are caused by the interaction of charged particles from the Sun, known as the solar wind, with Earth's magnetic field. As the solar wind approaches Earth, it is deflected by our planet's magnetic field, which acts like a giant shield, protecting us from harmful solar radiation. When these charged particles collide with atoms in Earth's upper atmosphere, they excite the atoms, causing them to release energy in the form of light. This process creates the stunning visual spectacle we see from the ground. The color of the aurora depends on the type of atom being excited and the altitude at which the collisions occur. Different gases and altitudes produce different colors, adding to the aurora's magical display. Volcanoes, awe-inspiring geological formations, are a testament to the immense power that lies beneath Earth's surface. These fiery mountains, capable of both creation and destruction, are also a source of natural light, their eruptions illuminating the night sky with a fiery glow. Volcanic eruptions produce light through a combination of factors. The most obvious source of light is the incandescent glow of molten rock, known as magma, when it's underground, and lava when it erupts onto the surface. Heated to temperatures exceeding 1000 degrees Celsius or 1800 degrees Fahrenheit, lava glows a bright orange-red, illuminating the surrounding landscape. In addition to the glow of lava, volcanic eruptions also produce light through the release of hot gases and pyroclastic flows. In the vast expanse of the cosmos, stars, like all living things, eventually reach the end of their lives. These celestial bodies, which have illuminated the universe for millions or even billions of years, face their ultimate fate. For some stars, this end comes in a spectacular explosion known as a supernova, an event so luminous that it can briefly outshine an entire galaxy. This dramatic finale marks the end of a star's life cycle. Supernovae occur in two main ways, each with its own unique set of circumstances and outcomes. One type, known as a type Ia supernova, occurs in binary star systems, where a white dwarf star pulls material from its companion star until it reaches a critical mass. This process can take thousands of years. This triggers a runaway nuclear fusion reaction, resulting in a catastrophic explosion that obliterates the white dwarf, leaving behind a cloud of stellar remnants. The other type, known as a core collapse supernova, occurs in massive stars that have exhausted their nuclear fuel. These stars are often several times the mass of our Sun. As the star's core collapses under its own gravity, it releases an immense amount of energy, blowing the star's outer layers into space in a brilliant explosion. This event can create neutron stars or even black holes. Thank you for joining us on this enlightening journey through the natural light sources that brighten our world. From the life-giving rays of our sun to the ethereal glow of bioluminescent creatures, we've witnessed the diverse and awe-inspiring ways nature illuminates our planet. Stay curious and keep exploring the wonders of nature. There's always something new to discover.